Association is about how two or more variables are related to each other. The measures of association include the covariance and the correlation. The covariance tells you how the variables co-vary. The correlation is the covariance standardized. The correlation ranges from -1 to 1, where -1 means the variables are perfectly negatively related, 1 means the variables are perfectly positively related, and 0 means the variables are not related at all. Let's go through how to calculate each measure. You can calculate either the population covariance or the sample covariance. You should calculate the population covariance when the dataset represents an entire population. You should calculate the sample covariance when the dataset represents a sample from the population. This is the formula for the population covariance, where for each observation I, x is the value for variable x, y is the value for variable y, mu x is the population mean for variable x, mu y is the population mean for variable y, and n is the population size. This is the formula for the sample covariance, where for each observation I, x is the value for variable x, y is the value for variable y, x bar is the sample mean for variable x, y bar is the sample mean for variable y, and n is the sample size. Suppose you asked 10 people how many meetings they had last Monday, variable 1, and Tuesday, variable 2. Each person is an observation. Your data set of responses is set out in columns A to C. You can apply the population covariance formula using the covariance p function. For the array 1 parameter, select the data in column B. For the array 2 parameter, select the data in column C. The output tells you that the population covariance is -2.04. You can apply the sample covariance formula using the covariance S function. For the array 1 parameter, select the data in column B. For the array 2 parameter, select the data in column C. The output tells you that the sample covariance is -2.27. Although you can easily enter a function, we'll also demonstrate how to apply the covariance formulas step by step. This may help you understand what the formula is doing. Step 1. Find the mean and number of values. You can use the average function to find the mean of each variable. For the parameter, select the data in column B or C. You can use the count function to count the number of observations. For the parameter, select the data in column A. Step 2. Calculate the deviation of each value from the mean. To find the deviation of the first value of variable 1, select the value, enter minus, and then select the mean of variable 1. Press F4 to lock in the reference to the mean. The output tells you that the first value of variable 1 is 2.2 units below its mean. You can do the same to find the deviation of variable 2. Copy the formulas in cells D2 to E2 to the rest of columns D and E. Now you have the deviation of each value of each variable from its mean. Step 3. Multiply the deviations. For the first observation, multiply the deviations of variables 1 and 2. Copy the formula in cell F2 to the rest of column F. Now you have the product of the deviations for each observation. Step 4. Sum the product deviations. You can use the sum function to sum the product of the deviations. For the parameter, select the data in column F. Step 5. Calculate the covariance. To calculate the population covariance, divide the sum of the product deviations by the count. To calculate the sample covariance, divide the sum of the product deviations by the count -1. Ensure that you put the whole denominator in brackets. The output tells you that the population variance is -2.04 and the sample variance is -2.27. This is consistent with the outputs from using the functions. You can calculate either the population correlation or the sample correlation. You should calculate the population correlation when the data set represents an entire population. You should calculate the sample correlation when the data set represents a sample from the population. This is the formula for the population correlation, where sigma xy is the population covariance of x and y, sigma x is the population standard deviation of x, and sigma y is the population standard deviation of y. This is the formula for the sample correlation, where Sxy is the sample covariance of x and y, Sx is the sample standard deviation of x, and Sy is the sample standard deviation of y. You can apply the sample correlation formula using the correl function. For the array 1 parameter, select the data in column B. For the array 2 parameter, select the data in column C. The output tells you that the correlation is -0.27. This indicates that the number of meetings on Monday is slightly negatively related to the number of meetings on Tuesday. That is, if you've had more meetings on Monday, then you'll have fewer meetings on Tuesday. There's no function for the population correlation formula. If you want the population correlation, you have to apply the formula step by step. That's why we teach you the formula, rather than just referring you to the function. Now, we'll continue from the lesson where we applied the covariance formula step by step. These are the population and sample covariances from that lesson. First, we'll calculate the population correlation. Step 1. Find the population standard deviation of each variable. You can use the stdevp function to find the population standard deviation of variable 1. For the parameter, select the data in column B. The output tells you that the population standard deviation is 2.86. You can do the same to find the population standard deviation of variable 2. The output tells you that the population standard deviation is 2.6. Step 2. Calculate the correlation. To calculate the population correlation, divide the population covariance by the product of the population standard deviations of variables 1 and 2. Ensure that you put the whole denominator in brackets. Now, we'll follow a similar process to calculate the sample correlation. Step 1. Find the sample standard deviation of each variable. You can use the stdevs function to find the sample standard deviation of variable 1. For the parameter, select the data in column B. The output tells you that the sample standard deviation is 3.01. You can do the same to find the sample standard deviation of variable 2. The output tells you that the population standard deviation is 2.74. Step 2. Calculate the correlation. To calculate the sample correlation, divide the sample covariance by the product of the sample standard deviations of variables 1 and 2. Ensure that you put the whole denominator in brackets. The output tells you that the correlation is -0.27. This is consistent with the result from using the function. In summary, these are the main measures of association, and how you can find them in Excel. In older versions of Excel, the covariance p function is called covar. There's no function for the sample covariance. For more lessons on statistics, visit alphas&betas.org.